Section 2.11, Implicit Differentiation and Related Rates. In our work up until now, the functions we needed to differentiate were defined in y equals f of x, with y given explicitly in terms of x, or as an explicit function of x. For example, y equals 2x plus 1 plus 3, y equals x squared plus 5x minus 10, y equals negative x cubed plus x minus 1, etc. So in all of these cases, y is given explicitly in terms of x. Y is function of x. Sometimes, however, we'll have an equation relating x and y, which is either difficult or sometimes impossible to solve explicitly for y, such as y to the power 5 plus 8y cubed plus 6y squared x squared plus 2yx cubed plus 1 equal to 0. Or y squared plus e raised to power y equals x squared minus 1. In these kind of situation, expressing those equations in terms of y equals f of x is sometimes difficult and sometimes impossible. So in such cases, it is not necessary to actually find the equation, explicit equation, okay? Instead, what we do is we use a method called implicit differentiation, which allow us to find the derivative of these kind of function. So in this section, we'll be focusing our attention on the method called implicit differentiation and then related rates. So two main concepts that we'll be talking about in this section. So I want to divide this section into two parts. In part one, we'll be talking about implicit differentiation, and in part two, we'll be talking about related rates. So the learning objectives for this unit is, by the end of this unit, you will be able to find the derivative of implicitly defined function using implicit differentiation and solve application problem involving implicit differentiation and related rates. So part one, as I said earlier, we'll be working on implicit differentiation. Okay, as discussed above, the key idea behind implicit differentiation is to assume that y is a function of x, even if we cannot explicitly solve for y. So while differentiating implicitly, we need to be very careful to treat y as a function when we differentiate and to use the chain rule. For example, let's look at this part A. We know that if we want to find the derivative of x raised to power 4, then because the variable is x and the variable here is x, then we can use the power rule. So that gives me 4x 4 plus 1, sorry, 4 minus 1, which gives me 4x cubed. Okay, but look at this in part A, in this example. We have y raised to power 4, but we are differentiating this with respect to x. So the technique that we're going to use here is that d over dx y power 4 equals d over dy, because if y is there, y raised to power 4, then if you want to find the derivative of this, we must differentiate with respect to y. Otherwise, we cannot use the power rule. We cannot differentiate it. So, but the technique here is that since we have dx there, but we wrote dy, so we cannot write extra thing. We cannot write whatever we like. So if we write something, then that must be cancelled. Dy, I wrote dy there, so dy cancel. So basically what I'm saying is that the left hand side and right hand side now are equal. So by doing this, they are equivalent expression, but by doing this, we'll be able to differentiate y raised to power 4. We'll be able to find the derivative of this. So the derivative of y raised to power 4 with respect to y using power rule, we'll get 4y cubed, and we're going to get dy over dx here. Okay, so whenever we have a different variable yx, then remember we're going to use the power rule, and then we need to write one extra factor. So what I'm going to do now is I'm not going to show these steps every time. So we go from here directly to that step. All right. So let's try part B. In part B, as you can see, this one is we will be using a power rule here. So you know the power rule. So d over dx of u dot v equals u dv over dx plus v du over dx. So you know the power rule. So u means x cube, dv is y raised to power 4 over dx, plus, let me copy v, which is x cube, and then, oh sorry, b is y raised to power 4. Let me copy that. And du over dx is dx cube over dx. So x cube, and using the same method as before, so y raised to power 4 is 4y cube, and then since y and x are different variables, so we must write that one factor extra using the chain rule as shown in part A, and plus y power 4. So this x and x, same variable, we can simply use the power rule, which is 3x squared. So our answer here is going to be 4x cubed y cubed dy dx plus 3x squared y power 4. So this is how we find the derivative of implicit function. Okay, so to find the derivative, I suggest you use those 4-step method. Step 1, differentiate both sides of the equation with respect to x. Step 2, apply the rules of differentiation as necessary. Step 3, isolate all terms with dy over dx as a factor on one side of the equation. And finally, you factor out dy over dx and then isolate dy over dx in order to get the final answer for the derivative. So for example, we need to find dy over dx using implicit differentiation for this function x squared plus y squared equals 1. Okay, so we are given the equation x squared plus y squared equals 1, and we want to find the derivative dy over dx. Again, step 1, differentiate both sides. Step 1, you differentiate both sides with respect to x, which means d over dx x squared plus y squared equals d over dx 1. So this gives me d over dx of x squared plus d over dx of y squared equals derivative of 1 is 0. So since x and x same variable, we will have 2x here plus y and x different variables. So we're going to use the power rule for this y squared, which becomes 2y. And since the variables are different, we write that one extra factor, basically using the chain rule, equals 0. Okay, step 2. We are done. Now, step 3, we want to write all the terms with dy over dx one side and the rest to the other side. So I'll write 2y dy over dx equals minus 2x. And the final step, step 4, is now you want to find the derivative dy over dx, which is negative 2x over 2y. That's going to give you negative x over y. That's how we find the derivative. Now let's look at another example. Here we need to find dy over dx given that 4xy minus 6y squared equals 10. So step 1, you differentiate both sides with respect to x. And now you can write this as just, separate them, equals derivative of 10 is 0. Now, as you can see, x dot y. So that is, again, we need to use the product rule. Product rule for this. So using the product rule, let me do it here. So d over dx of x and y. So this is u and v. Okay, so the product, using the product rule, we know the formula. U dv over dx plus b du over dx. So that's going to give me x dy over dx plus b means y, du means x over dx. So basically we're going to get x dy over dx plus y. So let me plug in that value. So 4, that's x dy over dx plus y minus 6 derivative of y square. You see y square, and then here x different variables, so we're going to get 2y, and dy over dx equals 0. So this will be 4x dy over dx plus 4y minus 12y dy over dx equals 0. All right, so now step 3 is just write all the term with dy over dx one side and the remaining to the other side. So you're going to get 4x dy over dx and minus 12y dy over dx, and then this, subtract 4y both sides, so you're going to get 4y. So this 4y will go to the other side. That's what you're going to get. Now this becomes dy over dx. You can factor out on the left hand side, which gives you 4x minus 12y equals negative 4y, and so your derivative dy over dx equals negative 4y over 4x minus 12y. Or if you want to simplify it, you can write this as negative y over x minus 3y. All right, so that is our derivative. Now let's try one more. Here we want to find derivative dy over dx for the equation 2y equals x squared plus sine y. So again, it's step 1. You differentiate both sides with respect to x, d over dx x squared plus d over dx sine y. So derivative of this will be 2 dy over dx equals derivative of this will be 2x, because x and x same variable, plus derivative of sine y, because y and x different variables. So what we do is derivative of sine y is cosine y, and since the variable are different, we write one factor dy over dx like that. Now our job is to bring all the term with dy over dx one side of the equation, which is 2 dy over dx minus cos y dy over dx equals 2x, and factor out dy over dx, so that you're left with 2 minus cos y equals 2x. So your final answer is going to be 2x over 2 minus cos y. 2x minus over 2 minus cos y. Okay, so one more example. Here we want to find the equation of the tangent line to the curve at the given point. So we are given a curve x squared minus xy plus y squared equals 7, and we want to find the equation of the tangent line to the curve at -1 and 2. So to find the equation of tangent line, we need the slope. We need slope of tangent line, slope, which is given by dy over dx. Remember the derivative, to find the equation of a tangent line, the standard formula that you learn in high school is y minus y1 equals m times x minus x1. So in another word, if we know slope and a point x1, y1, so if we are given a slope, if we know slope and a point, we can find the equation of a tangent line. The good news is the point is already given. So as soon as you are able to find the slope of the tangent line, you will be able to find the equation of the tangent line. So let us find out slope first. And slope of the tangent line is given by the derivative. We already know that from our previous discussion from previous chapter. Okay, so for this, let me just copy that. Okay, so we are given this equation. Let me copy that equation. X squared minus xy plus y squared equals 7. So differentiate both sides with respect to x, minus d over dx of xy plus d over dx of y squared equals d over dx of 7. So x and x same variable, so we'll get simply 2x minus d over dx of xy. We already calculated that in our previous example. Where is that? So we calculated this here. Derivative d over dx xy is x dy over dx plus y. Let me just copy that. X dy over dx plus y. Plus this one will be derivative of y squared with respect to x is 2y. Then since y and x different variables, so write dy over dx, one extra factor there, equals derivative of 7 is 0. And now 2x minus x dy over dx minus y plus 2y dy over dx equals 0. Now we want to keep all the term with dy over dx one side and the remaining to the other side. So what we got here is that negative x dy over dx plus 2y dy over dx on this side of the equation, and then this y will be positive y minus 2x. Now factor out dy over dx so that you'll get 2y minus x, or minus x plus 2y equals y minus 2x. So your derivative dy over dx equals y minus 2x over 2y minus x. So we found the derivative. Now the question is, what is the derivative at the point -1 and 2? So the slope m at the point -1 and 2 is given by m equals dy over dx, which is y means 2. Substitute the value there. Maybe let me just copy that as it is first. y minus 2x over 2y minus x, which gives me 2 minus 2 times negative 1 over 2 times 2 minus negative 1. So that will give me 4 over 5. Okay, that is the slope. Now we want to find equation of tangent with slope m equals 4 over 5 and passing through and the tangent line passes through negative 1 and 2 is given by y minus y1 equals m times x minus x1. So notice that this is our x1, y1 is there and m is there. So let me plug in the value now. So y minus y1 is 2 equals 4 over 5. X minus x1 is negative 1. So that's going to give me y minus 2 equals 4 over 5x and plus 4 over 5. So y equals 4 over 5x plus 4 over 5 plus 2, which means y equals 4 over 5x plus. This will give me 14 over 5. So this is our equation of the tangent line to the curve at that point, at the point negative 1 and 2. Okay, all right, so let's try one more question. Similar to that. So the graph of y raised to power 4 minus x raised to power 4 minus y square plus x square equal to 0 is called the Devil's curve. So if you draw the graph of this function, of this equation, then the graph, whatever graph you get it, and that graph, that curve is called the Devil's curve. So we want to find the equation of the tangent line to the curve at the point 1, 1. So first of all, to find the equation of the tangent line, we need the slope, okay? First, to find equation of tangent line, we need slope, which is given by the derivative dy over dx. So we want to differentiate both sides with respect to x, so that's going to give me, to find dy over dx, so differentiate both sides with respect to x. Since y and x different variables, so the derivative will be 4y cubed dy over dx minus x and x same variable, so you'll get 4x cubed minus y and x different variables, so you will get 2y dy over dx plus this one will be x and x same variable, 2x equal to 0. So now you keep all the term with dy over dx one side, and the remaining to the other side. So that's going to give you 4x cubed minus 2x. So factor out dy over dx. So you will get 4y cubed minus 2y equals 4x cubed minus 2x. So derivative dy over dx is going to be 4x cubed minus 2x over 4y cubed minus 2y. Okay. Or if you want to simplify it, you're going to get 2x cubed minus x over 2y cubed minus y. Okay, so now we know the derivative. We can find the slope easily. Okay, so slope of tangent at the point is given 1 and 1, is m equals dy over dx equals 2, substitute the value there, so x cubed means 2, 1 cubed minus 1 over 2, 1 cubed minus 1. So that's going to give you simply 1. Now we want to find the equation of tangent line, tangent with slope, equation of tangent with slope m is 1, and through the point 1, 1 is given by y minus y1 equals m times x minus x1. So now let us substitute the value. We know that this one is our x1, y1, point is given. So if I substitute the value, I'm going to get y minus 1 equals 1 times x minus 1. So y equals x minus 1 plus 1. So y equals x. So this is the equation of the tangent line to the Devil's curve at the point 1, 1. So this is how we find the derivative for the implicit function. All right. So in our next class, we use the same skill, same concept, same method, same idea to solve real world problems that is what we call related rates.